In this video, we will discuss about torsion. So here we have a circular bar and we are applying a torque at one end, the other end is fixed. So this end will not move and we are trying to rotate the other surface. So we are applying a torque. The length is L and the radius of the bar is R. Now if you see, after applying a torque, this surface will rotate by angle theta. Theta is the angle of twist. So this surface will rotate and this point here will come to here, but this point is fixed, so there will be this arc form which I have drawn here. So there is a phi angle on this side and there is a theta angle on the surface, means cross section. So over the length this phi angle will vary, over the radius this theta angle will vary. Now it is not varying, but it is on that length side and it is on this radius side. Now because it is fixed, it is same for all the radius, theta is same for all at all the points on the radius and phi is same for all the points on the length. So we can write the arc equation, which is phi into L equal to r theta, and for phi is a shear angle and theta is angle of twist. Now the torsion equation, and from this equation there is definitely one question every year in gate examination. Now T by J, T is we know that we applied the torque. J is a polar moment of inertia of this bar, which is pi by 32 d raised to 4. If it is a other shape we can calculate accordingly, but most of the questions are from the bars only. Tau by r, tau is the shear stress for which is generated inside the material, which will vary with respect to r, and at different value of r from 0 to the maximum value, which is capital R, this tau will vary, and tau maximum will be at the surface, means at the capital R. So there will be tau maximum. Now g theta by L, g is a modulus of rigidity of the material, theta is angle of twist as we know, and L is the length of this bar. So from this we can calculate all the variables which are asked in the question from the other variables which are given in the question. Now the first case we will discuss is when the tau maximum, we have to take r as capital R. I am subjecting tau, so r by r into t by j. So t into capital R divided by j. R maximum is capital R. So maximum tau will occur at a radius which is a surface radius, and t is a moment and j is a polar moment of inertia. So that is how we can calculate shear stress maximum inside the material. For different value of r, if we keep here a different value of r, small r, then we'll get different value of tau. At r equal to 0, we have shear stress 0. Now the second case is angle of twist. We can calculate by T L by Gj. T is a torque applied, L is the length, G is the modulus of rigidity of the material, and J is the polar moment of inertia. G will be given in the question, diameter will be given in the question, you can calculate J, length will be given, and torque applied will be given. If angle of twist is also known, then we can calculate other variable also like diameter from the J, length, and all other variable will be given. Sometimes we get questions of power, and power is equal to 2 pi nt by 60. So 2 pi nt means power equal to 2 pi nt divided by 60. So here number of revolution per minute will be given, revolution per minute, power will be given, so we can calculate t from here, and then we have to use these equations after knowing t, because in sometimes question t is not given but this power equation is given, and revolution, number of revolution for the shaft is given. So for a particular case of rotating shaft we can calculate torque from this equation and we can use this. Now the third case is shear stress again. Now here g theta by L into R. So here if we place R on this side, then g theta by L into R, we can calculate shear stress by, if we know all these variable like angle of twist. One important thing is here we will get we have to put it here theta in radians, not in degree. So if there is a pi, then we have to keep it as a 3.14 like that. And tau maximum we know it will be at R, which is R max, and that is capital R. So these are three cases from which any numerical can come from 1 mark also or 2 mark also. And thank you for watching this video, and see you in the next video.